So like I said, we're back into semester 2. Our first topic here is not so difficult. We're doing a new section, waves. I don't know, you wouldn't have done any waves like Lorraine, I don't think. Okay. Physics, waves. It's a pretty small section too. Okay. Go, come on. Here you go, here's your new book.
That's quite big.
Too big. Too big. Alright. I called it the wave equation, or you can call it wave motion. We're going to look at how waves move. Okay. You got that? Yeah? Yeah. Okay, so a couple of things to look at. First thing is that there's two types of waves. Progressive transverse, also called S waves, and progressive longitudinal, also called P waves. In the exam, they tend to use these words, transverse and longitudinal, but in some books they call them S and P. Okay, I can't remember why it's S and P. Forget, because here we call them transverse and longitudinal waves. So, what are the two types? Okay, so the first one is, now don't write this down because there's a lot of new words in it which I have to explain. I'll draw a picture, that'll help. So when you think of a wave, you might think of something like this. This is kind of like the wave everybody thinks about. And what's happening here is as the wave is moving to the right, you have this vibration which is happening perpendicular. So what's special about a transverse wave is a moving wave that is made up of oscillations. Oscillations means like this, which happens perpendicular to the direction of energy transfer. So this is the direction of the wave, or the direction of the energy. And these are the oscillations, and they're happening perpendicular. Okay? Basically, there's an up and down movement as the wave moves from left to right. Kind of the idea. Now, that's not the only way to describe this, but I think that was the simplest definition I could think of for this. And I'm sorry, they sometimes ask this in the exam. I've seen it a couple of times, the difference between each wave, so you're going to need to know it, okay? So can you write this down carefully? Matt, what happened to you? Tell me you went to B401, that would be funny. What happened? Oh, you are? I didn't notice. Come here, here's your book. chemistry, by the way? What have you moved on to?
Have you ever started chemistry?
I haven't.
After this, we have chemistry.
Is your first chemistry?
Yeah.
Oh, okay. You didn't have any last week?
No.
Wait, no,
Except for
this
the
is
exams.
Good labs.
just the labs. Yeah. How are the labs going? Are you doing the titration experiment?
Yeah.
And what's the other one she does? Titration, and
Distillation
distillation. The coffee distillation? Yeah.
and neutralization.
Neutralization, yeah, okay. Do you have to write up reports for all three of them?
No, just one.
Oh, that's good. Do you get to choose, or are you told?
Yeah.
Which one did you go for?
Titration.
I think most people choose titration.
I was going to go for titration, but then I saw the calculations.
Titration has the most calculations in it, does it?
I mean, I'm fine with calculations, but I saw.
Too many?
Yes.
Yeah. Okay, the next wave now is the longitudinal wave. And this is where the particles do not move with the wave. The particle movement is parallel to the direction of the wave propagation. This means the particles move left and right, which in turn make other particles start to oscillate. I'll have to explain this one. It's a little bit tricky before you write it down. So, oh, this is really hard, but okay, here's the air. And you have all your particles in the air. And then what happens is there's a wave, and what the wave does is it makes the particles vibrate, and then those particles that's vibrating, it hits a neighbour particle and it makes that one vibrate, and then that hits a neighbour and makes that one vibrate. But these stop. So it's like you have one here, it's vibrating, it hits that one and makes that one vibrate, and this one stops. And then that hits another one and makes that one vibrate. So the wave moves out like this. But the particles aren't moving. It's just one particle hits the next one, and then that hits the next one, and it moves out like that. So the oscillations is parallel to the direction. Can you...
Is it
like which one?
can I try it?
Yeah.
Something like a circle.
Kinda. It's hard to draw because you really need to see the movement, you know. You get the idea? So like if the wave is moving from me to you, then this one hits that one, and that one hits that one, and this moves forward. Okay? So the oscillations is parallel to the direction. Now there's a special word for the direction, which I didn't put in the first one, but I put in the second one. Wave propagation. So propagate, I don't know if you know this word. Do you know this word, propagate? No? It's a verb, and it just means to move. But you only use it when you're talking about waves. So you don't usually say a wave moves from A to B. You say a wave propagates from A to B. Propagation is the noun, meaning like the wave propagation being like the wave movement direction. Okay, it's okay. You don't have to use it in the exam. You know, in the exam when they ask for the definition, the key thing that they want to see is that you say that the oscillations is parallel to the direction of the energy transfer or the movement or the propagation. Parallel is the key word here. Okay, right? Can you carefully write this down? Now you don't need the last sentence really. It's just these first two. Got that? Got that? Yeah. Continue? Yeah. So, here's a picture I would like you to try and draw. I know it's difficult, but it's a good picture to show the difference. So, in the S waves, the progressive transverse, the vibration here is perpendicular to the movement of the wave. And this one here, this one's like a spring, and if you kind of give it a bit of a shake, you can see the wave run through the spring. You know those toys when you were kids? The spring toys? You know those ones you can flick it and you can see the wave run through it. Yeah, I have one at home. Maybe I should bring it in. Can you try your best to draw this? Okay. You got that? Yeah. Beautiful pictures? Got that, Kim? Big pictures, small pictures? Small pictures, tiny pictures. Okay. Continue, Andek? Yep. Okay. So, a little bit of vocabulary now for the parts of the wave. Maybe these are words you've heard before. So, this lowest point, have you seen this word before? There's a new word for you. Steve, have you seen this? How do you pronounce this? Good, yeah, trough. Trough and crest. Maximum and minimum. Okay? This word you might know from your maths class. Amplitude. Did you do this word in maths class? Or not? Amplitude. Yes, no? That's a new word? Yeah? And wavelength. Wavelength is the distance from the crest to the crest, or from the trough to the trough. It's the same. That's called the wavelength. You really need to know these. Sometimes in the exam, not often, but sometimes they actually ask you to draw a wave and name the parts of it. So, I know there's other words like, what's another word for crest maybe? What's another word you could give for this part? Any other words to describe this? Come on, don't be shy. Before I told you the word crest, how would you describe this? Top, yeah, good. Top, what else? Peak, yeah, peak, good. What else? Maximum, yeah. But in the exam, they want the proper physics word, which is crest, okay? So can you copy this as well, with the names? Okay, you drew this? Yeah. Chow, you got this? Yeah. Matt? Okay. Alright, let's continue. So, some terms now. Displacement x, that's how far the particles are moved by the wave. Amplitude a, the maximum displacement, is very similar to simple harmonic motion, isn't it? Wavelength, that's the length of one wave, from crest to crest or trough to trough. Period, well, you could probably guess now, the periodic time is the time taken for one wavelength to pass through. Now this is a new one, phase difference. The time difference between the crests of two different waves moving together. So I'll imagine you have two waves, here's one of them, and then here's another one moving with it. Try my best to draw it. Okay. So you see, if you draw a straight line down here, right, no, I'll do it from the crest. And then this one here. You see the crests don't quite line up. So this distance here, this is called the phase difference. If the phase difference was 0, then what you have is this situation where they match up perfectly. Okay, so that's phase difference. Frequency, you know the frequency, it's 1 over the time. It's how many waves pass through in 1 second. Speed, of course you know speed, how fast the wave is propagating. Move. Now not this speed, the direction speed, the propagation speed. Okay, so some of these words I'm sure are new, like phase difference, maybe wavelength. So you don't have to write all of these down, but at least write down the new ones that you didn't know. Which ones did you write down, Siva? Yes. Okay, can I continue? And you need a minute? That's no problem. Have you had your maths class yet? And what are you doing in maths? Product rule?
Yeah.
Just product rule so far? Quotient? How was your maths exam? It was okay. I didn't think it was too different to previous years. Similar, isn't it? Oh, yeah, I corrected your maths exam yesterday. Myself and John split the corrections. So I've bad news for you. You didn't get 100. Be strong. You did very well, but not 100. I think there were 2 questions where you forgot to write plus or minus. So like the answer was like m4 equals 81, so that m equals plus or minus 3, or whatever. You only wrote like 3. So you lose a mark, you lose a mark. The next thing you know it, no 100 for you. But that's okay. I'm sure Joan won't be too angry with you. Right. Are you in your own maths class, or are you mixed with anyone? You're by yourself? No, not yeah, okay. Right. Now, our first equation, only one equation for this lesson, the wave equation. And the wave equation, well, okay. Before I give you the wave equation, let me just remind you of some equations you already know. F equals 1 over t. You know this one. But we also have this new equation called the wave equation. And if you know the wavelength and the frequency, you can know how fast the wave is propagating. So you have v equals f lambda, where v is the speed, f is the frequency, and lambda is the wavelength. It's a simple little formula. Yeah, that's all there is to it. So if you can write this down, v equals f lambda. Now the reason I gave you this formula, f equals 1 over t, is because you can replace the f here sometimes with the 1 over t if you need to. Okay? You got that formula? Maybe you've even seen it before. Right. So, the other thing which they sometimes have in the exam is they want examples of each wave. So transverse wave. Which one is the transverse? The perpendicular or the parallel? Perpendicular one. So that's the wave that goes like this. Okay. So some examples of this type of wave. Light. The light moves this way. Ocean wave. What I mean, you know, when you're at the beach and you see the wave on top of the ocean moving across, up and down, up and down, up and down. And then, you know, if you have a guitar, the instrument, and you pluck it, the wave moves up and down as well. So these are examples of transverse waves. In the exam they might say, you know, a typical question might be, what is a transverse wave, and give an example. Something like that. Now, longitudinal waves. So sound is longitudinal. So the way the sound wave moves out is parallel. Underwater waves. So these are waves underwater. You know, if it's caused by an earthquake underwater, the way the water vibrates is longitudinal. And waves in a spring. So, you know, you have your spring bouncing up and down. This like in the picture, you flick the spring, the wave moving back and forth in the spring. These are longitudinal. So the easiest one, you know, light is the famous example for transverse, and sound is the famous example for longitudinal. Yeah? I think it's good if you write all the examples down, so then at least one will be in your brain when it comes to the exam, I hope. Got that? Yeah? Anybody play any musical instruments? None of you. You do? Which instrument? So what wave would that be? I guess it's like the guitar string, but it does. Yeah, I guess it is like it. How long have you been playing? How many years? Oh, very good. So, you must play for us sometime. Yeah, no? Okay, you got that? Yeah, the only thing I can play is video games. That's all. Right, I think maybe some of you are the same as well. Yep, okay. Right, so I think there's only one example I have to do because there's only one formula. So here's an example. A boy is sitting in a boat which is tied to the dock. I'll draw the picture, okay? The boy bobs up and down at a rate of once per 2 seconds. The boy judges the distance between the peaks of the ocean wave to be 4 meters. How fast are the waves moving? So what's happening is he's sitting in a boat. And there's the boat. And it's tied to the dock. Now the reason I said it's tied to the dock is because I don't want the boat moving left or right. Okay, and the wave is coming in. So this wave is making him move up and down. And this happens once per 2 seconds. So that means the t here is 2 seconds. So he's sitting in the boat and every 2 seconds he moves up and down. Like it's a 2 second cycle. He also looks at the waves and he thinks, the distance here is about, he said, 4 meters. So he wants to know how fast are these waves moving in to the dock, the V. So we have our formula, V equals lambda F, but we don't know the F. But we can use the other formula, 1 over T. So that's lambda over T. So that's 4 over 2. So the answer is 2 meters per second. That's how fast the ocean waves are moving in. A simple little question. So just write this example down. There's the dock.
Are we supposed to transit BF?
I think I did it okay. What's your question?
Is that the final answer?
Yeah, final answer, yeah. V equals lambda F, which equals lambda over T. Because F is 1 over T. Yeah? You wrote this down? Remember a couple of years ago, a student asking me, you have different words for dock. There's actually 3 words. Dock, do you know other words? Harbour and port. He was asking me what the difference was. I think the only difference is the size, I think. So, which is the smallest, dock, harbour or port? Yeah, maybe. Or is it harbour? I don't know. I'll have to look it up. Port is the biggest. Which would be smaller, dock or harbour? I think dock. Maybe. I'll have to check the dictionary. Anyways, not that it matters for the calculation. Dock, harbour or port. Okay, you got this one done? So you can see this lesson is pretty easy to get started with. Warm your brain back up. Now, if you notice, I don't have the answers at the back. The reason for this, I will put the answers in eventually, but the reason is what usually happens in semester 2, because there's less. Okay, so 2 things. Number 1, there's less to study in semester 2 than semester 1. There's less material, which is good. Okay, that's good. Bad news though is one of the topics students find quite difficult, fields. And then the second piece of bad news, or maybe it's good news, I don't know, the final exam is not quite 50-50. It's more like 60-40. 60% semester 2, 40% semester 1. So for the final exam, semester 2 is a little bit more important. So what I usually do each year is I do a tutorial on every worksheet. Like I do all the questions because it's more important for the final exam. So what will probably happen is after maybe 2 lessons, maybe every 2 lessons, I could do lecture, tutorial, lecture, tutorial, etc. So I'll give you all the answers. If you can't wait and you really want to see the answers, I'm sure you could find them on my YouTube channel from last year. Okay, but when's our next class?
Friday.
Yeah, I'll do all the questions on Friday from both lessons. They're very short. I don't think you'll have any trouble. So we've got a few minutes. I think there's only 4 questions. I think it'll only take you 5 minutes. If you can just take 5 minutes to do those 4 questions, then we'll have a look at the next lesson.